Hello everyone, meteorologist Matt Holiner, and on this edition of Weather Explained, let's go over a scenario that I bet has happened to you at least once and probably multiple times. You open up your favorite weather app on your phone, you look at the radar, and there's a blob of green over you. So it's raining, right? Except you walk over to the window, you look outside, and there's no rain coming down. So what's going on? You're experiencing Virga. So normally, there's rain or snow in the clouds. It falls, and it falls all the way to the ground. But not always. Sometimes there's rain or snow in the clouds. It falls, but it encounters a layer of dry air. And if that air is dry enough, or if that layer of dry air is thick enough, that rain or snow that's falling will evaporate before it reaches the ground. So yes, technically it's raining or snowing, it's just not reaching the ground. We call that Virga, and you can sometimes actually see it happening. Check out this picture. See those streaks of gray coming down from the clouds? That's rain falling, but notice that those streaks aren't reaching all the way to the ground. That's because it's rain that's evaporating before it reaches the ground. So this is Virga. And I will say this is a very unique picture because notice this is happening during a thunderstorm. See those streaks of lightning? This is less common. It is more common that Virga will occur when there's just a light shower and precipitation is light. But sometimes when a thunderstorm initially pops up, there's enough dry air around that the rain will start to fall but evaporate before it reaches the ground. But if it continues to rain, then the atmosphere does get saturated, that layer of dry air goes away, and then eventually that rain will start to fall. And I'll also say that because there's more dry air in the western U.S., Virga is more common in the western U.S., but it can occur anywhere. The problem is this still leaves us with one question. Why did the radar say it was raining when it wasn't? Well, this brings us to one of the problems with radar, one of its limitations. So remember that you've got a radar site and it's sending out a beam of electromagnetic radiation that's looking for rain or snow. And when it hits rain or snow, it bounces back that beam back to the radar site and says, hey, it's raining or snowing. The problem is the Earth is a sphere and it curves. So as that radar beam gets farther and farther away from the radar site, it is higher and higher in the sky. In fact, you get 50 miles out from a radar site, and that radar beam is 3,600 feet in the air. So 3,600 feet in the air, it may very well be raining or snowing. So the radar beam is right. There is rain or snow. But what it's missing is that layer of dry air that's in between 3,600 feet in the air and the ground. And it's missing that rain or snow that's falling at 3,600 feet is evaporating before it reaches the ground. So what this means is that the radar is less accurate the farther you are away from that radar site. And so what that means is that you tend to get more inaccurate information in rural areas than urban areas, because in rural areas there are not as many radar sites, the beams are higher up in the sky, so the information is less accurate. And the bottom line is, this is just another example, in case you didn't already know, that yes, sometimes your weather app is wrong.